Hey everybody, it's Mr. Carr again. Today we're talking about 7A Day 2, exponents. Okay, we got some more exponent properties. We're going to be talking about two specific types. What happens if we have negative exponents and zero exponents? Okay, so steps to simplify. There's a few different strategies here. My personal opinion is step one, make all negative exponents positive. And we'll talk about what that means in just a minute here. And then for the second step, apply the properties of yesterday. Okay, so apply multiplication and division exponent properties. Okay, so that's what our main two steps we're going to focus on today. So first thing, negative exponents. For any non-zero number a and any integer n, a to the negative n is the reciprocal of a to the n. Okay, so what that means is it looks like this. If I have a to the negative n, that turns into 1 over a to the positive n. This is why that works. Let's think about yesterday with our division, our quotient rule. Let's say I have x to the second over x to the fifth power. Okay, we know that I can write them out this way. I expand it out by multiplying all those together. Okay, if I cancel out, I get 1 in my numerator. There's nothing in the numerator besides 1. All the x's are gone. In my denominator, I have 1 over x to the third power. Okay, but remember what happened yesterday or the previous video. I can also apply the subtraction rule. I can do x to the 2 minus 5, which is x to the negative 3. So that means this has to be the same as this. That's what we're saying with this. X to the negative third is the same as 1 over x to the third power. So that's what we're going to look at. Now, when we look at this next example, okay, highlight this. If I have a negative example in the denominator, that means that's the same as doing the reciprocal, so with a positive exponent. So I could turn that into m to the third power over 1. Okay, so for part A, step one is I'm just going to make all my negative exponents positive. So b to the negative third, d to the negative fifth, they're just going to switch places. This is going to drop to the denominator. This will come up to the numerator. So c squared, d to the positive 5 over b to the third power. Do a double check. Is there anything I can combine through multiplication or division? All of them are different bases. So this is done. I don't have anything else to do for part A. Part B, just like before, 4 and 8, that makes its own fraction. So that is going to be reduced to 1 over 2. Both of these are going to switch to turn their exponents positive. So that'll be 1 over 2. And I'm going to have a to the 11th power in the numerator, a to the 10th power in the denominator. We'll do a quick check. Can I apply either multiplication or division properties? Yes, I can. So now I can do 1a to the 11 minus 10 power all over 2, okay? Which is, once I do my subtraction, it's just going to be 1/2 a. And that's it. All right, part C. Again, I'm going to go ahead and just do this. That's going to move to the top. It's going to move to my numerator. So it's going to be 5x to the third power over 1 times x to the fourth over b to the third power. Again, the only thing that moves, okay? The only thing that moves are the x's with their bases. So if x is the negative third, that's what moves. I didn't switch 5 and x, okay? 5 here is a positive 1 for its exponent, so I don't have to worry about changing that. Okay, from here, we can now put these together. So 5x to the third times x to the fourth over b to the third power. And now we can apply our rule, which is 5x to the 3 plus 4 all over b to the third power, which is 5x to the 7th over b to the third. All right. That's it for negative exponents. Last one for today is zero exponent property. Any non-zero number raised to the 0 power is equal to 1. Okay. So if I have anything, a to the 0, that just equals 1. So 15 to the 0 power is 1. If I put a fraction like this inside parentheses, raise that to 0 power, still 1. Real fraction instead of variables, 2 over 7 to the 0 power is 1. Okay. So after we apply that property, then the next steps we could take are other rules that we might do. So maybe we deal with negative exponents. Maybe we deal with addition or subtraction of the exponents. Bottom line is we look at this problem here. I don't have to do anything inside because it's all raised to the 0 power. It's just 1. Okay. For part B, the only thing raised to 0 power is this m to 0 power. So if I apply that, it's going to turn into 8n to the 3rd power over 16n to the 2nd power. I've got a fraction again. I've got 8 over 16, which is equal to 1 over 2. So I'm going to do that. It'll be 1 over 2. I have a quotient of n cubed over n squared. So that's going to be n to the 3 minus 2 power. So that's going to give me 1/2 n to the 1st power. Okay, and I don't have to write to the 1st power. I could just write 1/2 n. And that's it. Just anything to the 0 power. Just make sure that if it's inside parentheses, that whole thing is to the 0 power. So that's why it all went to 1. In this scenario, only m is raised to the 0 power. So that's the only thing that turns into a 1. Okay, I didn't write that part down, but it's just gone at that point. All right, so again, 2 main ideas here. What do we do with negative exponents? Okay, we can flip them to the reciprocals to make them positive exponents. Okay, but again, only the reciprocal, like only the base with that negative reciprocal changes. Down here, 0 exponents. So anything raised to the 0 power, it just automatically equals 1. All right, that's a quick one, but that's it for today. Take care, everybody.